see you all here this morning. The lesson this morning is 130 years of climate change in a place called Borðoyavík in the Faroe Islands. The area that we're going to look at, we're going to visit a little place that doesn't look like it is so exciting as it is when you come there. It is close to the shore in the second largest town in the Faroe Islands, Klaksvík. I will maybe start with telling you a little bit about where we are and where I come from. I'm a physical geographer, educated many years ago from the University of Copenhagen, and people with this education, they work with the processes on the surface on Earth or near the surface, on land and on shore, on the seabed, maybe on the sea. And often it's active processes in the environment as well as inactive, which you could understand as what happens in the landscape now and what has happened here years ago. That would be some things that people would be looking at with that are physical geographers. Then maybe a few words about the place where I work. I work at a place called the EDU-ARCTIC, which is the geological survey of the Faroe Islands. The survey has a lot of geoscientists. In our context, you say a lot. We're not that many actually. I don't know, 10, 12 people or something like that. We have a mineral collection. We have exhibitions at the National Museum. The scientists working at this institution work with the geosciences on land as well as offshore around the islands with for instance searching for oil or working with that subject, working with geotechnical issues on land, for instance, with tunnels and large building projects and many kinds of questions and research in the Faroese landscape and in Faroese context generally. The subject today is maybe a hot subject in many ways today, climate change, but it's not the usual subject like we often hear about the recent climate change that we are experiencing right now. It is it's climate change that has happened over a very long time, where we see extreme changes ranging from ice ages, where it's Arctic conditions much further south than today, to warmer periods like the period that we are experiencing today, that we call interglaciations, interglacials. So these, we're going to hear a little bit about these extreme climate changes that we've had on Earth for quite some time. And especially we're going to visit a place, Borðoyavík in Klaksvík, and look at what that place tells us. On this picture, you can see in the uppermost picture, you can see the mouse turning around here. There's the town Klaksvík, and where the yellow arrow is pointing towards is the site that we're going to look more at today, and we're going to see how we can read 130,000 years approximately of climate change in Borðoyavík, not in the Faroe Islands, but in the Faroe Islands. And the lower picture here shows you the site itself, and the locality that we're going to look at is just next to these boat houses on the shore in the southern part of the bay. So the lesson today we'll talk about climate change in more than 100,000 years. We will visit the locality in Borðoyavík, Faroe Islands. We will talk a little bit about the interglaciation and glaciation, the difference and the big difference between these two and what they mean. And we will talk about sea level changes in these periods. We will see how the climate change is quite extreme and following very big environmental changes. And we will talk about the Eemian interglaciation. Then the last point on the list is that we will end with a Kahoot game. The Faroe Islands, let's just start with placing them. It's a good reminder where they are in the eastern part of the North Atlantic Ocean, quite far from Iceland, from Norway, and from Scotland. And when we look a little closer at these islands, we see that it's 18 elongated islands, and the place, the locality that we will look closer at, Borðoyavík, is in the innermost part of this fjord, of this deep bay, Borðoyavík. That's the locality that is so exciting, and that we will look closer at today. We will here we go a little bit further in, and we see the bay, and the star here shows Borðoyavík. And when we go down to the shoreline here, the picture next to it, well, got a little quick. It's the same picture. That's okay. Shows us that next to these boat houses on the shore, we see a cliff, a coastal cliff, which doesn't look much, it's just a place, what's so interesting about that? But when you look closer, you see that there are some changes. In this picture next to it is a picture of this area around where I'm trying to point the arrows, and we can see that there's something here. The lower section is the rocks on the present shoreline. But then there is a layer in the lower part, and there's another layer which becomes a little darker on this picture. That's a little less than a meter thick, maybe, and there's something above that resembles the layer on the lower part, which is often chaotic with fine and coarse and big material, and then there is the upper part here. So the question is, what does all this tell us? Why is this so interesting? We see that in the upper part there are, let's start from the top here. So in the upper part we see fine sediments, and when you look more into it, it's placed on land. And then below that there are more coarse sediments with a mixture of rocks and finer material. And then there is this special layer here with fine sediments, and investigation in a lot of years have shown that there's a marine aspect in these sediments. And then below that, again, we have the coarse sediments, a great mixture of rocks and finer material. This has sparked interest for years and years. Maybe some of the oldest oldest work that has been where geologists have looked at it is probably this article from 1880, where a researcher from Scotland was in the Faroes and looked at it. There's a number of articles. I'm only showing a little bit of the work, just to give you a feeling of that it's a place that has been looked at a lot. There's the geologist of the Faroes, Lis Mortensen, who worked as a geologist in the Faroes for many years. Lis Mortensen wrote an article based on his research. The article is from 1972. There's some exciting work in the around 2000 and in 2005 some of that material was presented in an article in the Terra Nova, where they had used the tephra based correlation to date some of the material. And just recently, just a few months ago, a new article came, again looking at the macrofossil record of the fine sediments that we looked at before. And there's even one more article on its way, which has not been published yet. So why is it so interesting? The research has shown that let's go from the bottom, that in the lower part this is a material from an ice age. This is moraine material, so it's material where there's been a glacier flowing down the landscape, and it has this is material that has been carried with the glacier. And then the finer sediments that we saw in the middle section is from the last time there was a warm period after an ice age, just as we have today. The same kind of warm period, and it's called an interglacial. a period between two ice ages, an interglacial. And this last interglacial is called the Eemian interglacial, Eemian with two E's. And the dates of this layer gives us about 124,000 years ago. Then above that we have the last ice age. So the last time there was a lot of a glacier in the valley above Klaksvík, the town Klaksvík, and the glacier was flowing down the landscape and out through Borðoyavík, carrying much of this material with it. And above that, the youngest material here is from the present interglacial, the interglacial that we are living in, which is called the Holocene. So this is the Holocene material. Let's look a little bit about the times. The Quaternary period is a period lasting about 2.6 million years. The figure here goes 1 million years back in time from now, and 1 million years back in time. And we see through that period stages of glaciation. And what this section shows us is the period drawn in the red area here, where we see when it's very low, it's very cold, and when it's the black line is high, it's warmer time. So if we start from now, this is our present period, and the lowest part here is the coldest period during the last glaciation, the Wisel glaciation, and when we then go back to the high spike that we can see about 120,000 years ago approximately, that is the section that we can see in Borðoyavík, the fine sediments. And below that we see a part of the glaciations before the Eemian interglaciation. Through this time, very big sea level changes have happened. There are, we can see on this figure here, there are sea level changes that during an ice age, and a glacial time, an ice age, the sea level is 120, 130 meters lower than it is today, while during the Eemian, which is where the spike that is maybe similar that we looked at earlier, we see that during the Eemian, the sea level was higher than it is today, a little bit higher. And it shows us that the Eemian was warmer. Well, not this shows us, but we know from research that the Eemian was warmer than our interglacial. And that is what is so interesting with it. Let's just have a little question from Borðoyavík with the coastline. With the coastline, we're looking at here. What do you think? If we're looking at this marine material in the middle of the section during the Eemian interglacial 124,000 years ago, should we go outwards to the shoreline from that time, or should we go inwards to A for the former shoreline? So the former shoreline would be towards the figure A, the letter A. The Sal glaciation, the lower, we don't know if that is the lowest part of it, was more extensive than the last glaciation. The Eemian interglaciation, about 130,000 years ago to 115,000 years ago, was warmer than today, maybe 2 to 4 degrees warmer. Hippopotamus was found in Europe from that time, and global sea level was maybe about 6 to 9 meters higher than today. So what can we learn about climate change from the Eemian interglaciation? That's the big question. We know that Europe, during the last glaciation, which is called Wisel, had global sea levels which were about 120 to 130 meters lower than today. And this means that there was so much water frozen as ice on the continents, which led to much lower sea levels. And much land would have been dry at that time that is below sea level today, of course. So if we look at the, I asked you earlier about the interglacial coastline. If we look at the Ice Age coastline and look at the changes, the environmental changes through these 130,000 years, we see that the land would have been very, very different. The shoreline, our site was about where my arrow is, and the shoreline would have been maybe out where this yellow line is pointing towards. Some investigation, some research has been carried out looking for some of the older shorelines, but it hasn't been found yet. But we know it has to be outside, and if it's about 100 meters lower sea level than today, it is quite some distance outside the islands. So what we see is summary is 130,000 years of climate change in Borðoyavík. We can see that 11,000 years ago the 11,000 years ago the present interglacial began, while during the period 115,000 years ago to 11,000 years ago, we had the last glaciation where sea level was about 100 meters lower, 130 meters lower than today. And we know that the date 124,000 years ago, we had the Eemian interglaciation, which is this dark layer here with the finer sediments, with warmer climates than today, and sea level that was about 4 to 6 meters higher than today. And then the lowest part of the section showed us an earlier ice age, an earlier glaciation, which again would have had a sea level about maybe 130 meters lower than today, and the shoreline much, much further out than it is today. So this gives us all these 130,000 years of, you could say, extreme climate change in this little locality of Borðoyavík in the Faroe Islands. So with this, I would like to thank you for listening. If you have any questions, feel free to ask